Hey friends, you are gone today. It is Wednesday, September 20th, and I hope everything's okay. But this is a little update to let you know what you missed today. Okay, so this is the second part of the video. The first part of the video was where do you find your grades for your formative and your summative assessments? Infinite Campus. Then the next part was where do you find your grades for the homework you do and your daily participation? Google Classroom. So we got two places for grades. Infinite Campus, your assessments, standards based. Google Classroom, your participation and your homework. Okay. The next thing we talked about was seating chart, which will probably be for the rest of the unit. Just kind of we figured out which people work well together and try to get the best possible results from our team. That's in part one. And then in part two, we're going to talk about what we did today. So you're already in Google Classroom, beautiful, so you know where to go. And then now we're going to go to get into our ebook. So we're going to go to CPM Math. And I like to go to the one that says More Math for Every People. And then when we get there, we have to log in. If you have your Chromebook again, you can just find that Google G. If you don't have your Chromebook or you're on a different device, you may need to remember your school username and password. Go to log in, find the Google G, and then my account. From there we go to ebooks. And from there we go to course 3. And so we are on 1.2.1. Yes, 1.2.1. So this is called 1.2.1. How do they compare proportional relationships with graphs and tables? So in here, it says you may recall studying about proportional relationships in a previous course. Today, you will investigate proportional relationships in graphs and tables. So then we're going to say, well, do you remember what a proportional relationship is? So we'll go down to here and we'll recall that a proportional relationship can be seen in a table. If one quantity is multiplied by an amount, the corresponding quantity is multiplied by the same amount. On a graph, a proportional relationship is linear, straight line, and goes through the origin. 0. Proportional example, 3 pounds of chicken cost $7. 0 pounds of chicken cost $0. 6 pounds of chicken doubled, cost $6. 7 pounds doubled, cost $14. 9 tripled, cost 3 times 3 is 9. 7 times 3 is 21. So we can see it's proportional, right? It's going up by the same amount. It's linear. It forms a line. And it's going through the origin, going through 0. The relationship between pounds and cost is proportional. And here's a non-proportional example. The video arcade costs $5 to enter and $1 per game. So it's still linear. It's going up, right? But it doesn't go through the origin. The relationship between games and cost is not proportional. For example, someone who plays 4 games, $9, does not pay twice as much as someone who pays 2 games, $7. There's no multiplier for the relationship. The graph does not go through the origin. So let's remember that as we go back. Okay. The learning targets for today. Students will review what they learned in previous courses about proportional relationships using graphs and tables. They will also compare rates and different representations of proportional relationships. It says in this lesson, so now we're looking for our success criteria. Students will be looking closely to discern a pattern or structure. They'll be looking for and making use of structure, and the structure will help make sense of the problem, because we want to see proportional relationships and how you can multiply through in proportional relationships. Let's go back to here. The one that we're going to work on today is 142. And this is about Doug. And Doug is mowing his neighbor's lawn. And last month, Doug's neighbor paid him $55 for 6 hours of mowing. All right, so then we can open up the e-tool here. And then we're going to do this as a class and open up the e-tool. And we'll walk through this. It says, Doug regularly mows his neighbor's lawn. Last month, Doug neighbor paid him $55 for 6 hours of work. And then I'm going to say, is this situation most likely a proportional relationship? How do you know? So they're going to think about that as a group, and they're like, well, is this proportional? Number one, if he doubles his work, does he get double the money? Number two, if he triples his work, does he get triple the money? And then does it go through the origin? If he does zero work, does he get zero money? Then we have to make a table that shows how much Doug earns for various numbers, hours of mowing. So then we click down here to Doug's table, and then we see, well, 6 hours, he earned $55. And we can plot that point right there. So we've got 6 hours, $55. What if you mowed for 12 hours? We think that would double, right? What if he went for 24 hours of work? Would that double again? It looks like it. It looks linear. I wonder if he did 3 hours. So what's half of 55? Half of 55. I'm thinking $27.50. All right, that seems to work. What about if he did zero work? I'm guessing $0. Yep. Does that look proportional? It goes in a straight linear equation, right? It doubles, triples, it went through zero. Johnny brags that he is getting paid more than Doug to mow lawns. Johnny gets paid according to the graph below. Who is getting paid more? Well, let's look at Johnny's graph. Johnny said 25 divided by 2. 25 divided by 2. Does it look like Johnny's getting paid more, or does it look like Doug is getting paid more? At what unit rate do Johnny and Doug get paid? How do you know? Well, we could go into 1 hour. At 1 hour, it looks like Doug is here and Johnny is here. Okay, so it looks somewhere, a little over $9 an hour for Doug, and it looks like it's 10, 11, 12, $12.50. That makes sense. 25 divided by 2 is $12.50. How could we find Doug's unit rate? How could you find Johnny's unit rate? We could look at the graph. Unit rate means how much do they get in a 1? Or we could take 25 divided by 12. Or for Doug, you could take 110 divided by 12. Or 55 divided by 6. Or 220 divided by 20. They should all work out, right? Proportional relationship. And that's what we did in this part. So that's the one we worked on today. And then after we did this, we moved on to our homework. And the homework is talking about proportional relationships. And this is about video games. Now think about this one. We talked about, does this one go through zero? Each game costs $39.99, and there's a $4.85 shipping fee per order. How much will it cost to order any number of video games? Is that proportional? A given rectangle has an area of 20 square feet. What is the length for various widths? Is that proportional? Olga ran 8.8 miles in 1 hour 20 minutes. Assuming he continues at a constant rate, how long will it take him to run any number of miles? Is that proportional? Remember, if you need a hint to get started, you can go to your help. Jerome is keeping track of books, and he wants to make a box plot. If you need a reminder on how to make a box plot, please check your homework help. And then we went into simplifying the following expressions. Use your help as needed. And then look at each graph below, write a story about what each graph could show. This one is time. This looks like a proportional constant speed. Look at this one, time, speed went up, leveled out. What do you think happened there? And in this one, the time grew slowly, 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 and then exponentially took off. What happened there? Riley was monitoring the growth of his favorite tomato plant. He collected the data below. Graph it. And you can do this on an e-tool too to graph it. And what can you tell about his plant based on that data? Good. So I hope things are going well. If you need any help, make sure to contact me at johnsonth@mps.school. And I hope I see you tomorrow. And I hope you have a beautiful day. See you.